Hello friends, today we are going to discuss about the topic Radix sort. So, the contents of this video are introduction, algorithm, example, performance, advantages, disadvantages, and applications. First, look into the introduction of Radix sort. So, what is Radix sort? Radix sort is a sorting algorithm. It sorts the elements by first grouping the individual digits of the same place value, then sort the elements according to their increasing or decreasing order. The key features of the Radix sort are it works slightly based on the number system. It works in an omega in time complexity, but there is a certain catch. The elements that need to be sorted should have the same number of digits. The time taken by the Radix sort is directly proportional to the number of digits in the maximum element. So guys, now let's look into the algorithm of Radix sort. So, the first step of Radix sort algorithm is take the least significant digit of each element, and the second step is sort the list of elements based on that digit but keep the order of elements with the same digit, and the third step is repeat the sort with each more significant digit. So, what we basically do is we first sort the elements based on the value in the units place. Then we sort values based on the value of the 10th place. Continue this process until we reach the most significant digits. So this is what we do in basically in a Radix sort algorithm. So guys, now let's look into the example of Radix sort algorithm. So we consider this array as an example of Radix sort algorithm. As we can see that this array consists of 3-digit number, 2-digit number and 1-digit number. But we know that the elements that need to be sorted should be the same number of digits. So what we can do is that we can make all these digits into 3-digit number by making this 23 into 023 and by making this 1 into 001. Okay, then the first step of Radix sort algorithm is sort these elements based on the value in the units place. So we need to sort this in an ascending order manner. So the resultant is that we are sorted in a ascending order manner in the unit place. So the next step is we need to sort the values based on the 10th place. So the next step is to sort this 10th place elements in an ascending order manner. So the last step of this example is that we need to sort this most significant place in a ascending order manner. So this is the final result of this example. So friends, now let's look into the performance of Radix sort algorithm. The time complexity of Radix sort algorithm has three cases. The first one is worst case time complexity, and the second one is the best case time complexity, and the third one is average case time complexity. So the first one is worst case time complexity. In Radix sort, the worst case is when all elements have the same number of digits except one which has a significantly large number of digits. If the number of digits is the in the largest element equals n, the runtime is omega n square. So, in the case of best case time complexity, when all the elements have same number of digits, the best case scenario occurs. Omega a into n plus b is the best case time complexity. So, in the case of average case time complexity, you consider the distribution of the number of digits in the average case. There are p passes and each digit can have up to d different values. Because radix sort is independent of the input sequence, we can keep n constants so that t of n equal to p of n plus d, and is the running time of radix sort using the linearity of expectation and taking into account both sides expectations. So radix sort has an average case time complexity of omega into p star n plus d. The performance of Radix-Sort algorithm includes space complexity because Radix-Sort employs counting sort, which uses auxiliary arrays of sizes n and k, where n is the number of elements in the input array and the k is the largest element among the deep place elements, that is ones, tens, hundreds and so on of the input array. Hence, the radix sort has a space complexity of n plus k. So, the next thing involved in space complexity is the stability of radix sort algorithm. So, radix sort algorithm is a stable sorting subroutine based integer sorting algorithm. It is a sorting algorithm that does not use comparisons to sort a collection of integers. It classifies keys based on individual digits with the same significant position and value. Now, let's look into the advantages of radix sort algorithm. So, the first advantage is that it is fast when the keys are short, that is, when the range of the array element is less. And the second one is it is used in suffix array construction algorithms like Members algorithm and DC3 algorithm. And the third one is it is a stable sort as the relative order of elements with equal value is maintained. So now let's look into the disadvantages of radix sort algorithm. So the first disadvantage of radix sort algorithm is less feasible than other sorts because it is based on digits or letters. And the second one is that it has a higher constant than other sorting algorithms. The next one is that it takes up more space than quicksort, which is used for in place of sorting. And the fourth one is that it may be slower than other sorting algorithms such as merge sort, quicksort, if the operations are inefficient. These operations include sub-insert lists and delete functions as well as the process of isolating the desired digit. So guys, now let's look into the applications of radix sort algorithm. So, the first application of radix sort algorithm is that it can be applied to data that can be sorted lexicographically such as words and integers. It is also used for stably sorting strings. And the second one is that it is a good option when the algorithm runs on parallel machines because it making the sorting faster. And the third one is that it is used for constructing a suffix array. So guys, thank you for watching this video. I hope it may help you and have a nice day.